Take an iron bar, wrap a wire around it, run some current through it, and boom, it becomes an electromagnet. Reverse the flow of the current, and the magnetic poles flip right along with it. Now we have a magnet where we can control its magnetic field completely on command. And just like a permanent magnet, like poles repel and opposites attract. Let's tweak its shape. Put a spinning shaft right in the middle so it can rotate freely. We'll call this the rotor. Next, place two curved permanent magnets on either side. These are the stators. Turn on the power. The rotor generates a magnetic field. The like poles push away from each other, and it starts to spin. But wait, once it hits the perfectly horizontal position, the opposite poles attract, and it locks up. To keep it spinning, you'd need to constantly reverse the current to flip the magnetic poles. But manually flipping wires back and forth all day is a nightmare. So what's the fix? Being the genius you are, you attach two curved copper plates to the ends of the coil. This is the commutator. Then, you use springs to press two carbon brushes tightly against it, hooking them up to your power source. Now watch closely, here comes the magic. Power it up. Current flows through the brush, into the commutator, through the coil, and out the other side. The rotor is magnetized. It gets pushed away by the curved stators and starts spinning. When the rotor hits that horizontal dead zone, its own momentum keeps it moving just enough for the brushes to slide onto the opposite copper plate. The current automatically reverses, the magnetic poles flip, and it keeps spinning entirely on its own. But smart as you are, you quickly spot a fatal flaw. When you cut the power, the rotor will likely stop dead horizontal, attracted by the magnets. Right there, the brushes sit perfectly in the gap between the copper plates. Try turning it back on, it won't start. To fix this, you redesign the rotor and commutator into a 3-pole setup. In the real world, it looks exactly like this. Powered on, poles 1 and 3 act as south, while pole 2 acts as north. Pole 1 gets repelled by the right south magnet, pole 2 is pulled toward it, and pole 3 is dragged by the left north magnet. This creates a flawless clockwise spin, with the commutator constantly switching the poles to keep the motion going. Congratulations, you just invented the brushed DC motor. But do you know what the biggest weakness of a brushed DC motor is? Drop your answers in the comments below.